In class today, I introduced George Polya's problem-solving process. Here are the 4 steps, and what I want to do in this video is walk through some specific math problems using these 4 steps. Many of you probably already use steps 2 and 3. When you go to approach a problem, maybe a word problem or like an SAT problem or something like that, you devise a plan, you think of some way to solve the problem, and then you carry out the plan. The steps that get skipped more often would be steps 1 and 4, I think. You may take some steps to understand the problem before you begin solving it, but you may also just dive in right to steps 2 and 3. And similarly, I think many people skip step 4, but this is a good one to practice if you want to become a better problem solver. You want to look back over your problem, and we're talking about checking the answer and reviewing, making sure you've answered the question that was asked, but we're also talking about looking back at the problem in order to learn as much information as possible from that problem. So the whole point of problems is to stretch your brain and help to make some connections that can be useful in the future. So if you haven't thought about what those connections might be, or when in the future you could apply the strategies you just learned or practiced, then you're missing one of the key benefits of solving problems. Here's a list, and I did post some supplemental readings in the study resources folder for you, and I've drawn this list from one of those resources. But here's a list of many of the different strategies that people use to solve problems. So this would fall under step 2. Okay, step 2, devising a plan. So these are things that you can try when you want to approach a problem. Guess and test. This is a popular one. Drawing a picture, using a variable. Okay, and that allows us to, that kind of goes along with 14 here with solving an equation. Okay, we can use a variable and then perhaps write an equation and tackle the problem using algebra. You may want to look for a pattern, make a list, solve a simpler problem, draw a diagram, and so forth. In this video, I want to focus on some of these initial ones, and the readings that I posted also focus on those as well. Okay, so here's a problem, and what I want to do is talk through just step 1 to begin with. Okay, how do you demonstrate that you understand the problem, and what questions do you even ask yourself before you start tackling this to make sure that you understand the problem? This is important because you don't want to just dive in and start solving it and realize that you've missed some key piece of information that completely changes the way you think about this problem. So think through how many pieces of pizza can you cut with 4 cuts? Right, so some things to ask. First of all, do you understand all of the words in the problem? And in this case, the words are fairly simple, but some of them we may question in this context what they mean. So for example, what do we mean by 4 cuts? So some things you might ask yourself: do the cuts have to be straight? Or could they be curved? Right, straight cuts. Where do the cuts have to go? Do they have to go all the way through the pizza? Or could they just go part way through? What about the pizza? Is the pizza a round pizza? Is it one of those big sheet ones that's rectangular? Can we, for the sake of this problem, think of the pizza as some sort of a weird shape? Oops. There we go. Think of the pizza as some sort of a weird shape and then tackle the problem that way. When we say how many pieces, are we looking for the maximum number of pieces, which seems to be what the problem implies? Or, could we just say, oh, well, I can, make 1 cut and get 2 pieces. Is that sufficient? All right, so those are just some questions to start asking about this problem. For other problems, you may want to also ask yourself, do you understand the information that's given? So what do we know? And do you understand the goal of the problem? What are we trying to find? Is there extra information? Is there not enough information? And these are all good things to ask. So when you're writing out your steps for these problems, think about the answers to some of those questions, and that's what you would write about or think through for this first step. Okay, I'd like to look at another problem and go through all 4 steps in the problem-solving process for this one. So here's the problem. 84 dots are arranged to form the perimeter of a square. The dots are evenly spaced, with 1 at each corner. How many dots are on each side of the square? Okay, so first of all, we need to understand the problem. All right, so I would scan this through, make sure you understand all of the words. You may want to remind yourself what a perimeter is. All right, and at this point, it may even be helpful to draw a picture to understand this problem. Okay, so perimeter of a square, that's like the outside edge. Right? And rather than actually drawing an outside edge of a square, we're arranging dots to form the perimeter of a square. Okay, so we've got, dots something like this, and so forth, all the way around a square. Let's see, we need to know, well, what information is given. So that might be part of what you write down for understanding the problem. So we know that there are 84 dots total. All right, we know that they're evenly spaced. All right, so in other words, there should be the, what does that imply? Well, it implies that there are the same number of dots on every edge of the square. So they're not all squished onto one side or along one corner. And then we know that there are dots at the corner of each square. Okay, so we know that this thing will actually look like a square when we draw the dots. It's, not any sort of a weird arrangement. And then we also need to look at the goal of the problem. How many dots are on each side of the square? One thing that I see sort of commonly, I'll get a lot of answers that misunderstand this idea of each side, and I'll have students answer and say, and give the number of total dots, not understanding that we want like the dots along just a single side of the square. Okay, so that's important, understand the goal of the problem. So in other words, I've got this square arranged with dots, okay, 84 of them, all the way spaced along, so forth, all the way along, and I want to know, looking at just one side of the square, how many dots are on that side. Step 2, we need to devise a plan. So I'm going to look back at some of the options we have. I could draw a picture for this one. That seems like a good place to start. And I could also solve a simpler problem. I'd like to talk about that one as well. All right, so I'm going to pair those two together. Now, I may not exactly know, how to even draw this picture completely accurately because I don't know how many dots are on each side of the square. But what I can do is maybe start with a smaller picture or a smaller problem and then work up towards that picture with 84 dots. All right, so let me think first of all about just small arrangements of dots. Okay, maybe I want to do 4 on each side. All right, so I'll draw my 4 on each side. And then let me just observe how many total dots we have. Okay, so it seems like we have 12 dots. All right, maybe I also want to look at a square with 5 dots on each side. All right, and if you count those dots, then you'll see that there are a total of 16 dots. All right, so what we might try next, so I have my pictures, I might try thinking through how I found the total number of dots, right? And then think through maybe how I would work backwards, and then see if there are any connections to the case where we have 84 dots, right? So in the first case with the 12 dots, you may have just counted, right around the edge of the square, counted 12 dots. That's going to be maybe not the most efficient way to count as we start adding more and more dots to the sides of the square. Okay, so maybe instead you would want to think through some different options for counting dots. Okay, so when we get to 16 dots, all right, now something you might think is that there are, or maybe even if you were just trying to give like a quick answer here, you might hurry and think, okay, well, it's like 5 dots on each side, so 5 times 4 is 20, and actually it's not, there are 16. So you could maybe count along the top and the bottom and then maybe the sides, right? That would be one way to do it. Maybe you kind of shift things, so count from a corner in, okay, corner in, right, and then a corner to just before the corner, and so forth. Okay, so that could be another way to count the dots. And then the next thing you would want to do is try to figure out, is there some connection or way to count in an organized way that would help you know how to do this for 84 dots. Okay, so there are multiple ways to do this. One connection you might notice, 12 is 4 times 3. Okay, 16 is 4 times 4. Okay, and maybe you're thinking 4s because of squares. Squares have 4 sides, right? So notice that the 3 and the 4, okay, are 1 less than the number of dots along each side of the square. Right? So if you look at this first picture, that kind of makes sense because we want to try to count in such a way that we're not like double counting each corner. So if you count it in one side, then you would not count it in the other. Right? So maybe here you would think ahead and realize that 84 dots along a square. Right, we could kind of do the same circling method that we did for 12 dots, right? So maybe you would think through and think, okay, well, 84 dots is 4 times what? Right? And then maybe you would work from there to figure out how many would be along each side. Right? So in this first case, when I had 4 times 3, there were 4 dots along each side. When I had 4 times 4, there were 5 dots along each side. All right, so when there are 4 times 21 dots, then there would be how many along each side. Okay. All right, so you could have done, maybe lots of different things with this. Maybe you would have worked out a few more examples, drawn a few more pictures. Maybe you count the dots differently along each side. All right. But whatever you do, the next thing, so we've devised the plan. Step 3, so I'm going to write this out. Step 2, I tried drawing a picture. Oops, and looking for a simpler pattern or a simpler problem. And then step 3, I'm just going to show all of this work. Okay, so I'm carrying out that plan, drawing a picture and looking at simpler problems. Step 4, what can I do to look back at this problem? Right. Well, one thing you can do is check the answer to make sure that that we're correct. All right, so if you decided that there were 22 dots along each side, okay, so we've got, let's say 22 along here and so forth. Okay, and so forth. All right, so we've got 22 up here, 22, 22 along each side. Okay, but we don't want to double count the corners, so maybe I should only count, all right, the corners along the top and bottom edges, and then that would mean that I now just have an additional 20 on each side squeezed in between those. All right, so let's make sure if you add all of those up, then you can confirm and make sure that that equals 84. All right, so that'd be one thing you can do to look back. Another thing, what can you do to, it's looking back, but it's sort of also looking forward. What other questions could you ask yourself, or how could you apply information from this to different problems? Right? Well, natural extensions would be to just ask about different numbers of dots. So, you know, maybe you would want to ask how many total dots if there are 80 on each side. On each side. All right. Or maybe you want to know, can you make a square out of a certain number of dots? All right. So maybe we have 150 dots. Can we arrange those into the perimeter of a square? And you can come up with your own questions and go from there. Maybe you want to go back and study the different ways of counting the dots. Right? So I showed two of these, two different ways to circle and count. Is there maybe a way to go from there to write an equation to describe the number of dots, you know, total that you have based on the number of sides? All right, so those are just some examples to get you started with, you know, these 4 steps, and specifically 1 and 4 as part of this process. All right, I want to look at one extra example. Can we find the sum 1/2 plus 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the 4th plus and so forth, all the way up to 1 over 2 to the 10th. All right, so I'm adding a whole list of fractions here. Now I want to focus on just steps 2 and 3 here. Okay, so we've already done one complete example working through all 4 steps, but I wanted to show one more, maybe a different way to approach this rather than just entering this in your calculator, or you know, you could certainly search this online. There are more powerful computer calculators that could handle this. But here's another option. So let's look at the one solving a simpler problem. Now this might be a nice option if you just don't like adding fractions, or if you want maybe a way to save a little bit of time. Okay, so let's look at maybe just some smaller sums at first, right? So let's look at what happens if we just add the first single number. So if we're just adding 1/2, that's all we have. What about 1/2 plus 1 over 2 squared? Right, well that's 1/2 plus 1/4, which is 3/4. And then let's look at the next one. What about 1/2 plus 1 over 2 squared plus 1 over 2 cubed? Right, so that's 1/2 plus 1/4 plus 1/8, and that turns out to be 7/8. Right, and maybe one more. So 1/2 plus 1 over 2 squared, 1 over 2 cubed, and 1 over 2 to the 4th. Right, so this is 1/2 plus 1/4 plus 1/8 plus 1/16. Right, and if you add those, that ends up being 15/16. Okay, so now if you study this list of sums here, you may notice some sort of a pattern. Right, so you know, look at maybe the denominators first. Okay, 2, 4, 8, 16, And then notice back in our original sum here, these were just powers of 2, right? So notice that the answer, the denominator of the answer, is just going to be whatever that last power of 2 was. All right. So when I'm adding 1/2 all the way up to 1/2 to the 10th, right? A good guess as to the answer here would be that the denominator is going to be whatever 2 to the 10th is. And then how about the numerator? Well, 1/2, 3/4, 7, 8, 15, 16. Notice it's always just one less than whatever the denominator is. So if I can figure out 2 to the 10th and just subtract 1, that would tell me what the numerator is. All right? And that turns out to be 1023 over 1024. Okay, so is this faster than just entering this in a calculator? Maybe not, but if we go on and looked at step 4, what else can we do with this? Well, it gives you a nice option for calculating really, really large sums. Right? So what if I had asked, what is the sum 1/2 plus 1/4, 1/2 cubed, and so forth, all the way up to 1/2 to the 1,000th, right? So now you would have 1,000 different fractions to enter into a calculator if you wanted to actually do this by hand. But now using this pattern that we've hopefully found, we didn't prove it, but it's a likely pattern based on these examples, then maybe it would save us some time. We could guess the denominator is probably 2 to the 1,000th, and the numerator is probably just 1 less than whatever that is. Okay, so that's a little bit faster to do. Okay, so to review, here are the 4 problem-solving process steps, and what I want you to do for homework now is to solve, and I'll give you a choice of a couple problems, to solve your choice of those problems, and write out all 4 of these steps. Okay, so show some work that shows that you thought about how you would understand the problem and how you checked yourself, do you understand the problem? Choose a plan. Maybe you want to choose one from this list, right? Or maybe you have something else that works that you want to try, but state whatever that is. Carry out that plan. If it doesn't work for you, go back, try a different plan. Okay, show all of your work, even if it doesn't give the correct answer right away. And then maybe write out some things you could do to look back over the problem. So think through, how do you know the problem is correct? How do you know you solved it and answered the question? Is there anything you can learn from the problem? Any new problems you could create, or different problems that maybe now you have a shortcut to solve now that you've worked through yours.